Good evening, dear students, and good evening, ma'am.
Very good evening, sir.
Ma'am, okay, I'm here. I'll just introduce about yourselves to my students
Okay.
so that they will be aware of you and what are the contributions you have done to the technical community, scientific community. So I shall just list out few of the important data which I have got from you.
Okay.
So, okay, dear students, I would take this opportunity to introduce today's resource person, Dr. V.R. Anitha. Dr. Anitha is working as an associate professor in BMS Institute of Technology and Management, Bangalore. She has 17 years of experience in teaching and 15 years in research. So Dr. Anita has traveled widely and participated in international conferences and seminars in countries like Turkey, Malaysia, Portugal, and Italy. She published in about 18 SCI journals, 3 book chapters, and 29 papers in national journals and 33 conference papers. Dr. Anita has received grant for about 1 crore and 65 lakhs for research funded projects received from Ideas for New India, ISRO Response, DST, BDTD, DST FIST, and NP Mass Government of India. She has also filed a patent. She has produced 3 doctorates so far, and 5 scholars are pursuing PhD under her. She is a recipient of prestigious awards such as Young Woman Achiever Award, Travel Grant Award from International Union of Radio Science, General Assembly Commission, Turkey, received International Travel Scheme under Young Scientists from DST for oral presentation at Kuala Lumpur, Malaysia, participated in project competition in International COVID-19 Congress. The project has been shortlisted, one among the 32 projects from 600 project submissions. Today, she will be the resource person exploring the technical views to the program, MEMS, and its application. Thank you, ma'am, for accepting the invitation during your hectic schedule.
Thank you so much for your introduction.
Okay.
Yeah.
Uh, Dear students, hope this program will help you to get ideas in the field of mechatronics, which will be covered in a nutshell. Keep rocking. Thank you and all the best.
Thank you, sir. Shall I take the session, sir?
Yeah, sure, ma'am.
Yeah. So, first, I would like to thank the management of Rohini College and principal Dr. R. Rajesh and HOD of Mechanical Department Dr. D. Prince Sahaya Sudarshan and coordinators for the today's program Navin, Jass and Arjun Garu. So thank you for providing me the opportunity to share a few little knowledge with you, and I hope you will get some ideas through my presentation, and you can start. I think the participants are third year and final year students, no, sir?
Yes, ma'am.
If I'm correct? Okay.
Yes, ma'am.
So, yeah. So you can take some ideas for your project, and from that project, how you can publish the same work in conferences and in journals. So let's start with MEMS and its applications. So here, first I will give the references. What are all the reference books you can refer, and what are all the reference papers you can see. So here there are several books. I usually search for the contents related to MEMS, and I will share these reference books and the reference papers so that you can gain some knowledge through these books and papers, and you may also get some ideas through these references. So now come to the outline of my discussion. Today's discussion is, first I will go with introduction to MEMS. Then what are all the advantages of this MEMS and applications? And then why should we, I mean, where we can motivate ourselves to take up this MEMS. Then RF MEMS. What is the link between these RF and I mean MEMS kind of thing? How RF means it is a radio frequency. So where we are going to use this radio frequencies. So then MEMS characterization and RF MEMS limitations, uh, challenges, and how it is going to be related to communication. I don't touch this part, that is RF communication. So this is basically for electronics students. Okay. Uh, so when we enter into introduction to micro electromechanical system, that is MEMS. So when we consider the MEMS, it is the acronym, we can say it is micro electromechanical system. So if we consider this acronym, it was first used in the late 80s in USA. But the exercise of MEMS technologies can be, if you trace out, so all the way back to the 50s. So when we consider this MEMS, it is not only a name used to represent the field. Today, the people, they continuously using this name such as microsystems, microdynamics, micro machines, micro robots, and whatnot. So these are all using it for MEMS. So from the technological point of view, if we see from the technological point of view, so these names are basically the same, and the researchers have no problems in going to the same conferences or meetings to share knowledge with each others. But there is no doubt about that. For the last 20 years or so, the MEMS field has grown to be a big international high-tech field. So when we consider this MEMS technology, generally it does exist that we can define MEMS to be a functional unit that contains electrical or mechanical components with characteristic sizes which is ranging from 100 nanometers to 1 millimeter. This is very important. The size of the MEMS technology or MEMS device or MEMS component, if you take, the size is like from 100 nanometers to 1 millimeter. And if you take the device, the range of the device is from 1 to 100 nanometers. Sometimes this may go upper bound, that is from 30 nanometers or 300 nanometers. And all these, that is components or devices which are officially included in nanotechnology field according to many US national funding agencies, such as there are many. The best thing we can take it into the consideration of the NSF. So then these devices, if you made of components larger than 1 mm, which can be categorized into macro or meso domain. In other words, you can say that a device is a MEMS device as long as at least one component in the device has a characteristic size in the range of 0.1 to 1000 meters. right? So when we consider all these things, of course, not everyone completely agrees about this. For example, you can take some people simply they limit the overall size of your MEMS device to be less than 1 centimeter cube. And also here, one important thing you should understand is that MEMS devices, when compared to conventional devices, we should have one or more of the following, distinct features of miniaturization, multiple components, complex functions, system integration, and the ability of mass production. So even you can take it in other words like miniaturization or the smaller size. It's not only the emphasis, performance, and quantity, which are also important. So, and one should not miniaturize just for the sake of miniaturization. So these MEMS devices are expected to be smaller, cheaper, and better. So I hope you understand what is the importance of MEMS device and what for we are going with. So nowadays everywhere miniaturization, and it should be portable. So for all these things, we are making this MEMS device, and even a single component, if you are incorporating in a system, so that system you can call it as a MEMS device or nanotechnology or MEMS technology. So let's move on to the next one. Uh, like These are the recently developed MEMS devices, that is micro walls, optical switches and mirrors, micro pumps and micro flaps. So later I will come to all these things when I am going to discuss about the applications, different applications of MEMS. Now, it is even more interesting if MEMS can be merged not only with microelectronics but with other technologies such as photonics and nanotechnology. Okay, so now come to the advantages of micro electromechanical system. Here, before going to the advantages of micro electromechanical system, here my question is, why can't we write the entire 24 volumes of the encyclopedia on the head of a pin? So this statement was given by Richard P. Feynman. So why can't we write? I hope everyone knows about encyclopedia. So when you are going with encyclopedia, there are 24 volumes. So all these 24 volumes, approximately it has, each volume is containing almost 3-digit number of pages. So can we write those 24 volumes of content on the head of a pin? I hope everyone knows about the pin. So if it is the case, is it possible to write all the information on the head of the pin? I can say it is possible. So how it is going to be possible? Let's have discussion. So you take the head of a pin. You know what is the size of that head of the pin? 16th of an inch. 16th of an inch. If you magnify that head of the pin, you can magnify that head of the pin by 25,000 diameters. So at that point of time, the area of the head of the pin is then equal to the area of all the pages of the encyclopedia. I hope you understand. The head of a pin is a 16th of an inch. If you magnify that head of the pin by 25,000 diameters, then the area of the head of the pin is then equal to the area of all pages of the encyclopedia. Therefore, all it is necessary to do is to reduce in size all the writing in the encyclopedia by 25,000 times. Is that possible now? Yes, it is possible. That is the encyclopedia on the head of the pin. Let's consider all the books in the world and say there are some 24 million volumes of interest in the world. Of course, it would take the area of about a million pinheads, because instead of being just the 24 volumes of the encyclopedia, there are 24 million volumes. So the million pinheads can be put in an area of about 3 square yards. That is to say, the silica replica with the paper, which is a thin backing of plastic. So with which we have made the copies with all this information, which is on an area of approximately the size of 35 pages of the encyclopedia. So all the information which all of mankind has ever recorded in books can be carried around in a pamphlet in your hand and not written in code, but a simple reproduction of the original pictures, engravings, and everything else on a small scale without loss of resolution. That is more important. So that is the beauty of this MEMS technology. So how we are going to expand that pinhead, enlarge that pinhead into the 25,000 diameters. That is only possible with the help of MEMS technology or nanotechnology. Right. Now let's see the miniaturization. We keep on talking about miniaturization. So when we consider miniaturization, the picture speaks. If you see the first picture, so this is like a computer in the year 1946. So how much space is occupied here? Almost a big room, right? So from this stage where we are, this stage, a laptop computer in 1996. So you just compare these two. What is the size difference? It is almost 10 power 6 times down. And when you compare with the power, it is 10 power 6 times up. So that is another area where when power is increasing enormously, so during that time, what will happen to the human body? That is completely other side of the our talk today. So then from this also we have the computer which is like a palm top. So this was happened in the year 2001. So when compared to laptop and palm top, laptop the size is almost reduced from almost reduced 10 power 6 times, whereas palm top it is 10 power 8 times. But whatever the size you are miniaturizing, so the same amount of power is going to be increased. So here the idea is you can take up the idea. So when we are going with miniaturization, we are increasing the power. So because of this increasing of power, there are health hazards. At the same time, for the human body, it is going to affect. So even if we are miniaturizing the device, how to reduce the power consumption? That is one idea you can take up and you can apply. And all these spectacular miniaturization has taken place in almost 50 years of the duration. Here itself you can see 1946 to 1996 or to 2001. So all these, if you compare, it is almost 50 years duration it was happened. Similar way, if you apply the miniaturization to the mobile phone, so the demand nowadays, market demand is it should be smaller, it should be functional with multiple functions, and it should be robust, and it should also be intelligent. So all these are how we will get, so with the technology. So that miniaturization, here if you take the mobile phone, here so many engineering fields have involved to make this device. So mobile phones almost, this is not 10 years back, almost 20 years or 25 years back, 2.5 decade back, the mobile phone was like this. Then this is being transformed into like this. Then from this, the device is like this. From all these, now what we are using, we can't see any antenna on the mobile phones. It is inserted inside the mobile phone, right? So how it is going to be happen? So here, why I have taken this mobile phones as one of the example for the miniaturization. Inside we need to pack many functional components, then only it will become a device. So many small functional components, right, is going to be like different fields of specialization, like electronics is needed, mechanical is needed, and then the computer science is needed. So that means it is a multidisciplinary area. So for example, let's take nowadays a smartphone, if you take it into the consideration, it consists of, as an electronics area, it needs minimum of 4 antennas and maximum of 10 for each function. For example, one is for transmission, one is for reception, and one is for GPS tracking, and one is for video transformation. Like this, there are n number of antennas for each function. So all these antennas, if you are going to incorporate in a smartphone, then the power consumption is also going to be very high. So how to reduce or how to overcome this power consumption? Okay, so this is what I have discussed, why miniaturization, right? So there will be a precision movements and for rapid actuation. So that means either move or stop more quickly due to low mechanical inertia. Therefore, this is ideal for precision movements and for rapid actuation. And also, if you consider this miniaturization, which are going to be suited for biomedical particularly and aerospace applications due to their miniature of size and weight. So I will show how it is going to be applicable for biomedical and aerospace because of this miniaturization and weight. And it also has a higher dimensional stability at high temperatures, and which also allows the packaging of more functional components in a single device and less material requirements. Okay, now I hope you understand what is the introduction, what for we have considered, we have taken up this MEMS, and what is miniaturization, why we have to go with miniaturization, what are all the advantages if we go with miniaturization. And now let's come to the applications of MEMS. We will go with, there are plenty of applications. Everywhere you can apply this MEMS technology. So each application individually, we will see how the MEMS components are going to be incorporated in those applications and how it is functioning. So if you take all these are applications of MEMS, those are aerospace, automotive, biomedical, chemical, optical displays, wireless and optical communications, space and defense, whatnot. I might be missed few more applications, but major applications are these. Now let's consider one by one. So the same thing I have represented like this, MEMS or NEMS, which are applicable for many things, aerospace, information technology. In pictorial view, you can see where we can apply this MEMS and NEMS technology. So individually, if we go first, let's consider automotive applications, because as a mechanical student, how you can help, how you can take up the problem, and how can you solve those problems for the societal need. So everyone aware about the car. So this is a car which is having I have given numbering everywhere, right? So what for? Basically, without seeing all these things, a car's automatic toll collection you can we are doing. So and also it can car identification and location. If you are going to keep your car in multi-story parking garage, so that how you are going to identify and how you are going to locate your car. So that is the major problem nowadays in cities. So these two are main applications why we are going with MEMS technology. And now you come to the numbers. One is where here in driving seat, right? So here, what is the MEMS technology behind this? And everyone knows that is like airbags, right? So if any collision happens, the airbag will open and it will protect the human being. Am I right? Okay. So how it is going to be done? Okay. So here micro accelerometer, right? So that micro accelerometer is going to perform, it is like a MEMS device, or we can simply say that it is a sensor. So how it is going to protect, open the airbag, and how it is going to protect, I will show you. So for that purpose, at this location, one MEMS component we are using, I mean it is being used. Then two, right? So if you consider here, there is a solid state micro gyro, so which is for active roll or pitch control. So I hope your mechanical students, you can understand all this terminology. So third is in the tire. So tin oxide based microchemical sensors, which is going to be used for exhaust system or pollution control. Then fourth one, if you consider, so here micro sensor based ignition and fuel injection control, that is inside your bonnet. And 5 is like a smart door and seat and wall coverings and trim panels will be available at this position, which gives active sound control. So usually if you are playing the tape record, we are getting sound beats from the side doors. So that is active sound control. So then 6 is electronically steerable antenna, so which is going to indicate the that means which is going to be used for collision avoidance and actively control brakes and steering. Then 7 is global positioning mini sensor, that is for tracking, and 8 is like a ice detector on road surfaces, which is going to be very useful in other countries. And 9 is like what we can say, that means a wireless tire pressure sensor. So which is going to be which is going to give indication that the tire is having nowadays nitrogen gases we are filling. So how it is going to be, how you are getting even in the modern cars or latest cars, if you see, so you will get even in the tires, if air is less, you will get the indication. So this way the MEMS technology is going to be used in the cars. And when you see few examples how the tire is going to have the pressure, right? So that MEMS device, or simply we can say sensor, which is located in this area to perform a real-time interior air pressure monitoring, right? So one remote sensing module, which if we kept inside each tire, and a receiver module that brings the information to the driver. So like that, that's what I told. When you keep the sensor here, or when it is inserted in the tire, it will let you know what is the pressure level of the tire. So accelerometers, this is very important. I am not touching all the parts where important things are there, so there I'm just stressing. So even if you take how can we design this one, there are plenty of limitations for this existing sensors. So how to overcome those limitations, you can take up as a problem, and you can solve by applying this MEMS technology. So accelerometers, if you see here, the airbag is opened. How this airbag is opened? Once airbag is opened, if you hit the airbag, right, so you don't have that means that this airbag is going to protect you. So how it is being done? So you just see, this is the position, this is the airbag, you don't know what is happening inside. So if you take here, the sensor is being inserted, So that sensor, when car hits, or we can say that any collision happens, at that point of time it gives the indication, that means that pressure is going to touch this sensor, and then immediately this sensor activates the inflator. From this inflator you will get the nitrogen gas. This nitrogen gas is going to be like how we are I mean how we blow the balloon. What is the gas we are giving to blow the balloon, right? So from the human beings we are getting carbon dioxide. So with that we are blowing the balloons, and here this is going to give nitrogen gas, and that gas is going to protect the, I mean, which blows the air back, and it is not going to uh, it is going to help the human being. So this way how the sensor is going to be going to help the human being in a car. Now you may ask the question that what is there to do to take up the problem. So every thing there will be some limitation. Even if you take a person, we can't expect 100% everyone likes us. So some 10% or 20%, there will be always some negativity. Even you can take now the example, whatever I am just speaking, everyone can't be understand. If it is going to be understand by I mean, if it is going to be understood by 100 people, 100%, then it is extraordinary, I can say. So at least 1-2%, that is limitation. So that whatever the negativity, that we have to take it as a limitation. So everything, even whatever, why every day by day, why the technology is being improved, and the mobile phones, why they keep on upgrading the devices. If it is not going to be upgraded, then we would have not having all these portable devices today. Okay, so here if you take a few collisions, so sometimes the airbag is not open, right? So if it is not going to be opened, then automatically the human being will get affected. So when the human being affects, he or she may lose their lives. So why it is happening? Is it the failure of airbag, or is it the failure of sensor? So there you can take up the problem. Okay, so now even different cars, different kinds of MEMS technology they are going to use. So here if you see the first picture, this is Philo, that means Italian for wire. So drive by wire, that is the concept. So which was demonstrated by Italy's, which is Style Bertone and SKF Group. So this car is based on the Opel Zafira minivan. The interior lacks pedals, gear shifters and a steering column. Then how it is going to be? Now I hope everyone knows about Tesla. So if you program that Tesla, where do you want to go, and at what speed you want to go, if you program that one, without you can sleep, or you can lie down, or you can do whatever you want. So that will take you to the destination. So then the second figure, if you look at this, so the drivers communicate their uh, intentions to the vehicles, which is operating with operating systems electronically. So via smart electromechanical actuating units, which is integrated as sensors. You can see on the bottom, I mean, the floor of the uh, car, you can observe that there are different sensors which are arranged in a uniform way. So these are all the advantages why we should go with the MEMS technology. Then coming to the next application, which is aerospace application. If you look at the aerospace applications, there are plenty of applications where we are using these MEMS devices or MEMS components in the aircraft. So one among those everyone knows the wing of the aircraft. So if you take the wing of the aircraft, which loads testing that is going to be used with pressure belts. So you just observe the wing of the aircraft. It is going to have several panels. So each panel is going to have some MEMS device, which is incorporated MEMS device. So that is, even next time when you are going to travel, you just observe the each wing of the aircraft is going to have several panels, and each panel consists of one MEMS device or MEMS component. So that is going to be Boeing pressure belt, which is nothing but by using MEMS technology, they made this pressure belt. So the circuit which is used inside this pressure belt is like this, and that pressure belt, you just see now here it is a panel. So inside that panel you have the MEMS device, that is pressure belt using MEMS sensor. So that circuit is like this, but what are all the components? You just see, right? So it is consisting of the connector tab, then the coating. What coating? That coating is also MEMS coating, MEMS material they are using, right? So there is a MEMS device, and there is a chip. So that is flip chip bonds and IEEE bus wiring traces and tap carrier end of next module. So many things are incorporated in a single panel. So here also, if you there are several limitations, so those limitations you can overcome with the help of your the MEMS technology. So then you just see, this is like the wireless MEMS interior sensors for these helicopters. So you have blades here, 4 or 5 blades. It will any helicopter is going to have, right? So that blade vortex interaction sensing and control is going to be done with the help of MEMS technology, and it is going to drag sensing and control and cabin noise sensing and control, all these to be done with the MEMS technology. Okay, so and engines, that is also made with the MEMS technology. You can see here flame detector, which is one type of sensor, and pressure sensor we have, and fire detection, for that one sensor we are going to use, and speed sensor to sense the speed of the aircraft, it is going to be another sensor. Then temperature, to know the temperature or the torque of the engine, and fuel or oil to identify fuel or oil content, that is like a pressure sensor, and to monitor the fuel or oil. So for that also one more sensor we are going to use here. And you have the shaft torque sensor, so which is going to be used for optical blade temperature sensor, that is to know the temperatures, and thermocouple manifold. Then other sensor which is a pressure sensor, which is going to discharge temperatures, and flame detector if any flame occurs. So to detect that one sensor, flame detector sensor, is going to be used here. And like this, there are several sensors in the jet engines. So, and the micro that rods are going to be used here. Those rods size is 150 micrometer diameter, and the length is like 500 micrometer, and which is spaced on 1 centers on a 1.7 centimeters diameter rod. So which was happened in the first, it was happened in USA. So then if you see the health monitoring of jet engine, whether it is controlled, or the health of the engine is okay or not, for that also there are several sensors. Here the antenna is one kind of smart sensor, which is acting as a smart sensor. Then accessory sensing, we need one sensor, and the combustion process we need one more sensor. And here these are the turbines and power plant which is going to be sensed. And we have wireless MEMS for vibration sensing and health monitoring of this engine. So then one more application if we consider, which is nothing but medical application. So if you look at the medical application, there are several ways how we are going to use MEMS into the medical field. So even nowadays, you are at home, complete your health is going to be monitored by your a personal doctor. How it is going to be happened? Anytime have you think in this way, right? So elders in your house or in your home, elders are there. So their elders' health, how we are going to monitor? So immediately how the doctors are responding to them and controlling their health issues, even they are remote from each other. So which are all like a personal health monitoring, which receives and analyzes data from a number of sensors, that is ECG, EMG, blood pressure, pulse oximeter, glucose level monitors. And also nowadays many people are facing the cancers, so that cancer detection and also general health monitoring you can done with the help of MEMS technology. So then once tracking and monitoring of doctors and patients inside the hospitals, so how it is going to be helpful each other, I'll show how it is going to be happen. So it is a micro machine transducer which is going to monitor the general body of a person. General body monitoring completely. So with this single device, this is the MEMS device. So you just see this device is having readout system, right? So then you have IV line, and you also has it also has blood pressure sensor, and another IV line. One is for input, one is for outcome. So with this you can monitor the complete body, just how many places they have kept the MEMS device. Here this is one and this is another one. So with these two you can monitor the complete health of the person. And also we are using always intelligent pills. So what is this intelligent pill? What it is going to be done inside the human body, right? So if you look at the intelligent pill, inside that pill, what are all the components you have? This is simply we can say MEMS device, and on this MEMS device board you have several sensors. So each sensor is going to monitor one kind of health. So that means that this intelligent pill function is we can say that it is a multifunctional sensor system. So telemetry and micromechanical systems for sampling and drug dosage. One purpose we are using this. So what is going to happen as soon as a patient swallows that intelligent pill, right? So we as soon as patient swallows that intelligent pill, we are going to expect to collect the information concerning the patient's health problem, and which is going to be analyzed, and finally which release the liquid medicine to cure it. Right? So all these analyzation and delivery system is expecting to have a diameter under 1 centimeter of size, this intelligent pill size. So now where the research is going on, when anybody swallows this intelligent pill, then sometimes it is going to be failure. Then at that point of time, how it is going to be affected the human body, and also how to take out of that pill from the human body, right? So to avoid all these things, once it may analyze the health condition of the patient, but it can't deliver the medicine to the patient. So all these are sometimes, that is 20% problems are there. How to overcome those problems? So the researchers are working on this. So here one more problem you can take up. A small things you can take up for your mini project or project, and you can solve. Even if you choose one problem for your mini project, you can continue the same problem till your main project submission, for your main project submission. So at that point of time, you can present that your idea or your whatever the solution you have given in conferences, symposiums. So there you may get a few comments from the audience, from the experts. So with that comments, you can also work more on that, and finally you can publish the same thing in reputed journals. So here this is the let's see this picture. So this is the diseased area. There are two areas which is not normal to the other area. So this is affected area. So that means you just see this one. This is a nano blade. So by sending this nano blade, you can normalize this area, affected area. So what will happen when you have affected area in your body, right? So that means when it is going to happen. So when you have fatty materials are going to be deposited on the arterial walls, which causes the blockage in the artery, right? So it can be possible. How to remove that one? It can be possible physically by using this nano blades. right? And also, a few people, they may have the tumors over the period. If your area this is going to be affected, so then it is going to become even tumor. So nowadays it is a great threat, and that tumor pieces which can be carried out to other locations, and what will be the result? We can say that it is a cancerous cells. Those are all cancerous cells. So how to avoid, how to overcome this problem? So one effective approach is to kill the cancerous cells, right? So which is going to be enclosed the entire tumor in a nano box, and which is going to be destroyed everything in that box. So that is the beauty of MEMS technology. So you just see here graphical representation of nanorobots, how it is going to work in a blood vessel to remove a cancerous cells. So you just see first picture, you have you can sense there are so many cells. We can say that there may be good cells, there may be cancerous cells. So that is another research topic. So if you consider, if you want to differentiate the normal cells and cancerous cells, there are plenty for each part. There are different devices we are going to use to identify, that to early detection of those cancerous cells. So that is the hot topic nowadays. So almost all the researchers are working on that. So here I proposed one solution to identify, that is for the cervical cancers. So I proposed one solution. So for that, the DST biomedical department, they have sanctioned 40 lakhs rupees to carry out this work. So from here you just see here these two, or it is this is the MEMS device, so which is identified only cancerous cells, and it is going to capture inside that MEMS device, and you just see completely captured or absorbed. Once it is going to be absorbed, then it crushes that cancer cell, and it will just after crushing it leaves. So once it is crushed completely, so it can't affect anything or anywhere else. So that way, what is this device, and what is the technology they used in this, all these things, it is separate one talk we need to discuss about this. So but here I'm giving where you can take up the problems and what for you can take up the problems. These ideas I'm giving. So if you are really interested, you can just contact me. So I will provide how to approach or how to proceed with that problem. So like this, there are plenty in medical field nowadays. MEMS technology, how it is ruling the medical field, I can say. So forceps, this is, you just see forceps. With this forceps, the retinal surgeries are doing nowadays. They are doing retinal surgeries with this just a simple forceps. So you can imagine this simple forceps consists of MEMS devices or MEMS technology. So with that MEMS technology only it can be happen. So then you just see smart tongue for food packaging. This is one of the application. This is I'm not that much expert to discuss about this smart tongue. Then smart nose. For this, I think IIT Bombay they have developed a sniffer dog. So how the sniffer dogs with the Air Force people or police people they have for bomb explosives, how these sniffer dogs are going to identify those bombs. So for that, sometimes it will blast. So when it blasts, there will be human, I mean, persons, people in and around, and there also almost all the human beings will lose their life. So to avoid that one, by using this sniffer dogs, it identifies, it smells the bomb explosions, so it can identify. It is like a robo, it seems to be like a robo. So IIT Bombay developed about this kind of sniffer dogs. So what are all the challenges in biomedical science? So there are broken bones. That means in accidents we are going to have broken bones. So how it is going to recover? How we are going to recover from that broken bones? So we are using nanotechnology. How you are going to use the nanotechnology? It is the diamond coating. By using diamond coating for the rod or whatever we are going to use. So for that diamond coating, we are going to make use of this, and we are going to overcome the broken bones. And another one, bone grafts. So for that carbon nanotube, it is a tube like a structure. So this is like a nano materials MEMS material. We are going to make this nanotube to carbon. To bone grafts. So then you can also see you can also compare. So these nanotubes which are in the same structural family as have you heard about buckyballs? So when you heard about buckyballs, this is seems to be similar family, which is similar family of buckyballs, but rather than a spear shape, it is a cylindrical. So these nanotubes like buckyballs are made up of carbon atoms, and they are very light and very strong. So they are going to make an excellent scaffold for tissue to grow on. So in the future, the nanotubes could possibly be injected into our bodies. So that way, I have taken one example how it is going to be helped to overcome those problems. Then drug delivery, I already discussed how it is going to deliver the drug. Then disease diagnosis. So I told you how the cancer cells are going to be detected by using micro cantilevers. You can still you are welcome to propose some solution to this disease diagnosis. So by using micro cantilevers. So in military, those are all medical applications. In military, how it is going to be useful, that is MEMS sensors, which are spread on the ocean floor, which could detect the presence of enemy submarines, one way. And the other way, it is going to be used in anti-torpedo weapons on submarines and ships. And also the responsibility of these sensors are going to be denoted the torpedo at the right time hitting. That means torpedo to should be hitted the target at the right time in a crowded environment. So that means it prevents any premature explosion. So that is the beauty of this. So like this, there are plenty of applications if you consider military. So if we keep on talking about this, I think 2 hours or 1.5 hour is not going to be sufficient. It's almost running out of the time. So I'm just quickly showing the pictures how it is going to be useful. But the main part I almost covered, the as a mechanical student, where you can take up the problem and give the solution. So the if any civil engineers are there, so they can also use this MEMS technology to monitor the building health, building or bridges health. And even in forests, we keep on seeing so many forests, there might be fire. So that forest fires also you can monitor with these MEMS sensors. So I can say, if any person like the movie Guzarish, if you have seen, you would have understand with the facial expressions, so or facial twitches, the wheelchair is going to be moved. That means the commands are going to receive by the wheelchair or computer. According to that, it can move on. So this is one beauty thing, how the that means the MEMS technology is going to be useful for the physically handicapped people or blind people also. So what are all the sensors we can insert in our body? One is to feel. So few people, they can't feel. So for them you can insert this mechano receptors, so to feel. So auditory system for audio problem, if anyone is having audio problem, they can go with this sensors, that is MEMS sensors. Visual system, that means blind people. For blind people, we can insert the MEMS chip on the eyeball. So with that, they can see, they can get the vision, and that means they can that chip is going to, that means MEMS chip, that is a sensor which is going to give the instructions by identifying what is there in front of them. And all these, they can't see, but they can, it will instruct the person. So and for nose, for smell purpose, that's what I said. So sniffer dog. So like this, we can insert the sensors even in a human body. So what can be sensed? So many things you can sense with that, that is pressure, temperature, flow rate, radiation, chemicals, pathogens, whatnot. So this is what I said. So MEMS based chip is going to be inserted in the retina for a completely blind person, right? So then biosensors for large number of gases, that is for fragrance. Then electronic tongue to taste. Then this chip is used to detect chemicals in gas, liquids, and DNA. So then medical and homeland security applications like biocavity laser, uh, decontamination foam, smart pill, sensors for missile systems, all these. Then biocavity laser, this is going to distinguish cancerous from non-cancerous cells, so that we can, I mean, surgeons can easily do the operations when they go with physically. So decontamination foam, right? And marine science also, there are plenty of MEMS sensors or MEMS technology or nanotechnology we are going to use. So here I will stop, and you can take up this MEMS technology in any area. So like civil, mechanical, the MEMS itself, it is like it is not a single discipline, it is micro electro mechanical system. So we can make the hardware part, but who is going to provide the programming. So computer science people, or even you yourself can do that computer programming. So autonomous underwater vehicles also we are using this MEMS technology, and big oil explorations. So there also we are using finding potential oil and gas reserves, all these things. Then coastal weather monitoring, we are going to use this MEMS technology like this. What not? Everywhere this MEMS technology is being occupied. So now you just tell me what is the importance of this MEMS technology now, and unknowingly in and around you, most of the devices are occupied with MEMS technology. So now here I'm going to do the concluding remarks, like technology will change our lives and the way we conduct our day-to-day activities. Then major technological breakthroughs will be interdisciplinary and which occur at the fringes of classical disciplines. Engineers, scientists, and technologists will need to be trained with the depth as well as breadth of this MEMS technology, and learning to work in teams, which will be the most important one, right? And here verbal and written communication skills will be indispensable. Then finally, we can say that it is a cost effective and efficient manufacturing techniques, and process will play a vital role in determining whether a technology is merely a laboratory curiosity or whether it can be commercialized. So always you should look at commercialization, right? So could you please tell me if technology is being improving, so will it going to affect our future? Can you imagine, right? So no one can imagine how the technology will affect our future. So the best way to predict the future is to invent it. Finally, I can say the best way to predict the future is to invent it. Don't buy anything. Don't depend on anyone. So you just invent it. So with that, I conclude my session. Thank you, everyone, and thank you very much, Brito sir, for nice
Thank you, ma'am.
introduction, and yeah, and you have. I think you are also one of the organizer. So yeah, thanks a lot, sir, and thank you once
Thank you.
again
Thank you,
for
ma'am.
the management. If you have any queries, it is forum is open to you.
So students, those who have any queries can ask questions. Abhirami?
Even if you are hesitating to, I mean, raise the questions now, you can also send an email. My email is with Brito sir and the coordinators. So you can just email me. So I will reply.
So, dear students, if you are having any doubts, any clarifications, you can ask. Prince, sir?
Yes, sir. I can.
Ah,
I
so you can conclude.
okay, 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 sir. Wait a minute. Good evening, one and all. Respected madam, dear Brito sir, faculty members, and my dear students. Today section was very informative. Though the title is related with the MEMS, it is a little bit new for mechanical engineering. But nowadays, mechanical engineering without MEMS, we cannot achieve anything. From the madam talk, we can learn lot of things. Madam very clearly explained from the introduction part and application part. Nowadays, ma'ams in widely part in the medical field also. Madam clearly explained. Madam really useful as ma'am. Some of the students are afraid to asking the question right now. That's why still now they are maintained silently. Definitely we will ask more questions through the mail and other options. Already Brito sir told you. Madam really once again entire the mechanical department, faculty members, management. We would like to thank you. You spend a lot of time for us, even though you are a hectic schedule, but accept the simple invitation. So really, thank you, madam. Very lucky people. Definitely, I request you. Definitely, the day will come one time. If possible, you should come directly in our college. We will arrange the one program, which program that will be definitely useful for us, ma'am. I request to you, if possible, as you are convenient, we can arrange the program, ma'am. Once again, I thank the Dr. Bittu sir. He put lot of effort to arrange this program. He is one of the backbone to bring the resource persons for this program. Once again, I thank you, sir. Again, I thank this program coordinator. Thank you, professors. And once again, I thank those who are listen this program. Thank you, thank you. Definitely, this program useful for us. Little bit knowledge gathered our student. Then we should follow. Definitely, it will useful for us. Once again, I thank you. Thank you. Thank you. Thank you all.
Thank you so much, sir. So
Thank you, madam.
definitely in future, I will associate with you, and you
Sure,
are
madam.
the
Sure, madam. Sure,
backbone.
sure,
Yeah.
sure.
So yeah,
I request you. We want to.
sir.
I request you. When it is possible, you should come and give detailed lecture for us. It will be very useful.
Definitely, sir. Just I
Yes,
have
yes.
given
Thank you. Thank you. Thank you.
structure, skeleton
Yes,
of the MEMS technology.
yes,
So
ma'am.
in
Yes,
that,
ma'am.
if I go, I should take one in detail, one
Yes,
application
ma'am.
as
Yes, ma'am.
in detail how the MEMS technology is going to be
Yes, ma'am.
applicable
Yes, ma'am.
for.
Yes, ma'am. Yes, ma'am.
So
Yes.
definitely
Yes.
in future, I
Yes,
will
ma'am. Yes.
associate with you, and
Yes, sir.
I'll do. Yeah.
Yes, sir. Thank you. Thank you, ma'am.
Thank you. Thank you, Brito sir. As
Thank
sir
you.
said, backbone, you are the backbone of this
Yeah,
program.
yeah.
All these
Sure, sure,
backbones
sure.
will
Sure.
not appear front.
Yeah,
So,
yeah,
yeah,
ma'am.
thanks a lot for your, I mean, effort and, effort to make this program successful.
Thank you. Thank
Thank
you,
you,
ma'am.
all the
Ma-
participants.
Yeah,
Thank you, ma'am.
ma'am. Few students will be contacting you
Yeah,
regarding some projects related to mechatronics.
sure.
So, if possible, you kindly support them.
Sure, sir. Definitely, I'll do.
Okay. Thank you.
Thank you so much.
Thank you. Thank you, ma'am. Thank you.
Yeah. So I'm just leaving the call, sir. Yeah,
Okay.
yeah.
Thank you.
Thank you.
Thank you, ma'am. Thank you.